Hello and welcome to our Discover the Maths in Maps lesson, which is part of our Discover More Festival at Explore Learning. Thank you so much for joining us. My name is Bryony and I'm delighted to be with you all. This lesson is for children who would like to discover the maths of maps. Now, I absolutely love maps and maths, and I hope you enjoy this lesson too. We are going to look at some of the key features of maps, how to read coordinates on a map, and as a challenge, we will then look at how to convert measurements on a map to real life using the scale. After this session, if you want to watch the video again, you can, whilst completing some of the suggested activities. But for now, if you could please have a pencil and paper ready for the session in case you want to write anything down. Okay, let's get started. So, my first question for you is, what is a map? I'm going to give you about 10 seconds to write down your ideas. Okay, brilliant. Now, a map is a diagram to represent a land or sea area. Okay, and there are two main types of maps. Although we could make a map to represent so many different things about the world, the two main types are physical and political. Now, maps can show physical features such as rivers, mountains and deserts, and a political map shows human features such as buildings, roads, towns and countries. Now, there are 5 key features which are often associated with maps. I wonder if you can think about what those 5 features are. Perhaps have a look at the map on the screen to see if that gives you any idea what one of those 5 features might be. I'm going to give you a moment to write down your. We're looking for 5 key features of a map. Okay, so you may have thought of the title. Now, most maps do have a title, and it helps us to understand what is being shown in that particular map. You may have written down the grid, which is really useful for us to be able to locate points on a map. You can see here that this map has a grid. There are some lines going up and down the way, and we also have some lines going across the way. That is what's known as the grid. And we're going to find out a bit more about that today. You may have written down the compass rose. You may have spotted that here, just there. A compass rose helps us to see what direction we are looking in when we're looking at a map. So usually north is at the top of a map, but not always. So it's important to have a look at the compass rose as well. See, we should have 2 more features. How about the key or legend? Key is really useful for us to understand what the symbols on a map represent in real life. And we'll be having a look at a key of a map today. Scale is also useful. Scale indicates to us how large something is in real life. And again, we are going to explore scale in more detail today. So moving on. Now we're going to have a think about the maths in maps. I have a question for you. I would like you to think about what are the mathematical elements of maps. So what is the maths in maps? I'll give you about 10 seconds to write down some ideas. You may be able to think of 3 or 4 examples of maths in maps. Okay, we're now going to start to think about the mathematical element of maps. So I have a question for all of you, which I would like you to write down the answer to. What are the mathematical elements of maps? So what is the maths in maps? I'll give you about 10 seconds to write down some ideas. Brilliant. Okay, so some of the ideas that I thought of that you may have written down are the compass rose. So this is really useful for us to be able to understand direction. And you can see here this compass rose has north, south, east and west. So it helps us to understand where places are located in relation to each other. We've also got to make things more accurate. We've even got northeast, southeast, northwest, southwest. Again, just really, really helpful when we're looking at direction on our map as well. You may have thought about the key. A key is mathematical because it uses symbols on the map to represent real landmarks or real features, okay, in the real world. You might have thought about the scale. We are going to look at this in more detail today, but you can see here the scale on the map that we're looking at is 1 centimetre equals 10 metres. So 1 centimetre on our map represents 10 metres in real life. And that we can use our mathematical knowledge of times tables to help us to calculate conversion using a scale. So that's really useful. You may have also noted down the grid, which lays underneath the images which make up a map. And a grid is also mathematical. We have numbers along the sides and we've got evenly spaced lines which are there to help us to locate places on a map. So lots and lots of ways that maths is incorporated in maps. Also, maps can help us to solve mathematical problems, such as working out how long it might take us to travel from one place to another, how far away our school is, for example, from our home. Okay, so we can use maps to help us with mathematical problems. Okay, we're now going to consider the mathematical element of the grid in a map. So here we have, around the edge of a grid, we have 2 axes. This one here, which is horizontal, across the bottom here, is the x-axis. And this one going up here is the y-axis. So the vertical axis here is the y-axis. Now the grid is made up of horizontal and vertical evenly spaced lines as well. So we see here we've got other horizontal lines going across the grid, and we've got other vertical lines going up and down the grid as well. And placed on both of the axes are numbers, and these are really useful for us if we want to start to give the coordinates, so the location of different features on the map. To find a point on the map, we shall first of all read along the x-axis, so this one here, and then we're going to read along the y-axis to give a second number for the y coordinate. Okay, let's put this into practice. So for example, I want to find the coordinate of this triangle. Okay, on our map here, see just about there. So my challenge is I want to find the coordinate of the center of this red triangle. Okay, so let's have a look together. First of all, I'm going to move along the x-axis here until I need to stop at the line where the triangle is placed. So I've stopped here at the 7 because the triangle is placed on this line. Brilliant. So we can pop this on our board here to help us with our coordinates. So we've got, first of all, we've got the number 7. Okay? And then because we're writing coordinates, I'm going to pop there with a comma after it, I'm going to sit the 2 numbers within brackets. And that's what we do if we're writing out coordinates. So 7 is our first number. Now we're going to have a look along the y-axis along here. We go all the way up and we stop at the line there, which indicates where the triangle is located. That was the number 8. Okay, so our y coordinate. Okay, so for our triangle, we have coordinate 7. Okay, now let's try the next one. So Okay, let's have a look at the square. I'm going to pop the square down here. Okay, I would like you to have a go at writing down what you think the coordinates are for the square. Then we'll have a look together. Square. We're going to go along the x-axis here to the number 4, and then we're going to go all the way up here, and we can see here that it reached the number 3. So the coordinates for our square are 4, 3. Board here. Again, we put them in brackets, and we have a comma in between the two numbers to separate the number that represents the x-axis and the y-axis. Brilliant. Okay, one more to try. Let's see what the coordinates are for the centre of the orange circle. I'm going to place it here. Okay, so I'll give you a moment to think about it. Where do you think the circle is located? Good. Circle. Let's do it together. Oops. Okay, so we're going to go along here. So we're going to count 1, 2. Go. We can see the circle is located at that there because it's up. And we're going all the way up to number 9. So the centre of the circle is located 2, 9. Okay, well done if you got those correct. Work, brilliant. Okay, now we're going to move on to think actually locating landmarks on our map. So we had our blank grid and we looked at coordinates and we used shapes to have a practice of our coordinates. Now we're going to think about landmarks, okay? So we'll make a bit of space on here. Go. So we can now see here that a map has been placed over the grid and the map shows interesting features of my local area. We can now use our knowledge of coordinates to correctly indicate where places are on a map. So I wonder if you could try this one yourself. Can you write down the coordinate for the bottom left-hand corner of the school? So use the key to help you. Have a look and see which symbol represents the school. Okay, and I'm looking for the coordinate for the bottom left-hand corner of the school. Let's have a look together. Okay, so the school I've spotted is here. It's at the top of our map. So let's check our x-axis first of all. We're going to move along to the number 1. Then we're going to go all the way up here to the number 8. Okay, so the bottom left-hand corner of the school is located at point 1, 8. Well done if you got that one correct. Fantastic. Now we're going to have a look at finding the location of my house. Now I live in this house here, the blue one. And I wonder if you could have a go at writing down the coordinate for my front door for the blue house. That's my house there. The front door of the blue house. Have we got it? So my home is located at, let's move along from here, 0, 1, 2, 3, 4, 5, 6, 7. I'm moving up the map here to number 2. So our coordinate for my home is 7, 2. Fantastic work, everyone. I think we're getting the hang of it. We have now practiced how to give coordinates for landmarks on a map. Brilliant. So you're using your mathematical knowledge to explore maps and locate landmarks. Excellent work. We're going to have a go at the challenge now. Going to see if we can think about how to calculate distances on a map. So let's give us a little bit of space on the board. Okay, so we're now going to look at the mathematical feature of scale on a map. And what is scale used for on a map, and how can we use maths to solve problems? Okay, so the scale is used to convert distance on a map to the real distance on the ground, or vice versa. It's the other way around. So when you're creating your own maps, you will consider the distance on the ground and convert it to a smaller distance on the map using a scale. Okay, so here we have the scale at the top here, and we can see here that it says that the scale is 1 centimetre equals 10 metres. Now this is really important for us to remember. I'm going to pop it up here. So our scale, the map that we're looking at today, is 1 centimetre equals 10 metres. Okay. We can use our times tables knowledge to calculate how large features are and how long distances are in real life. Let's try one together. Okay, what is the length of the school building? You remember from before, we've got the school building up here. Okay, and I can see that the school building is approximately 1.5 squares, grid squares wide. Okay. Now, one of our squares is a centimetre wide. So if we've got 1.5 squares wide, that means that it is 1.5 centimetres for the width on the map of the school. Okay, so let's pop that up here. 1.5 is 1.5. So 1.5 centimetres on the map equals what in real life? That's what we're trying to work out. Okay, so using my scale of 1 centimetre equals 10 metres, I can do a simple conversion calculation. So to convert the numbers, I'm going to multiply 1.5 by 10 to give me the number of metres. So 1.5 multiplied by 10. Yeah, 1.10. You can have a go at that for me. That's correct, well done. That equals 15. And we're converting from centimetres to metres. So it equals 1.5 centimetres on the map equals 15 metres in real life. Fantastic. So that's the width of the school building in real life. Now let's try to calculate a distance using the scale of a map. So my question for you is, how far is it from the school to my home? Let's calculate this approximately using our map. Okay, so remembering that each square is 1 centimetre wide, I'm going to use my little pointer to take us on a journey. Okay, we're going to start here at the school, and we're going to follow a route from the school to my home, which remember is the blue house. I'm going to move along here. This is approximately 1 centimetre, 2, 3, round the roundabout, 4. Now we're travelling south over the river, 5, 6. Now we're going to travel east along this road, 7, 8, past the shop, 9 to this crossroads. Now we've got to turn right at the junction, 10, 11, 12, 13, okay? So it's approximately 13 centimetres on our map, the journey from our school to my home, okay? So I'm going to pop that up here. Let's make some space for this distance calculation. Remembering that our scale is 1 centimetre equals 10 metres. And we said that our distance on the map was approximately 13 centimetres. I'm We're going to do the same thing as before. 13 multiplied by 10 equals, if you can try it, excellent, 130. Okay, and we've converted from centimetres to metres. So I'm going to remember to put my units here of metres. So 130 metres is the approximate distance from the school to my home here. Fantastic work. So it's really important to have a look at a map when you're given one to see what the scale is, and it will help you to understand how to convert distances. Okay, and we've done a couple together today, so well done. Let's move on. Now, here is a little challenge for you. After this lesson, you may want to try drawing your own map of your local area. It's important to remember to include the 5 features associated with maps. Now, I wonder if we can remember them together. So the first one is title. Brilliant. The second feature, we usually include a key or legend. And it is useful to have a grid to place your features onto. We can include a compass rose to help us with directions. And there was one more that we spoke about today, which is scale. Fantastic. Okay, and if you keep the scale fairly simple, it may help you to convert real life distances to the distances on your map so that you can try to keep things in proportion to each other. Fantastic. So let's have a look at these 2 examples here of some maps which have been drawn by children. So let's look at the top here. We've got title, fantastic, my town on this one. This one's where I live, brilliant. They've both included a key at the bottom. Here's one and here's the other. Some fantastic features labelled on there. For example, my house, the shop, the beach and a woodland area. This one here's got my school, a playground, really good idea for playground symbol there, and a farm. They have placed their maps onto a 10 by 10 grid, which really helps you to keep things in proportion and think about sizing. So that's a good idea. We can see a compass rose up here, and these maps are facing north. There we go, another compass rose there. And they've used the scale that we've spoken about today in our lesson, 1 centimetre to 10 metres. So you may want to have a go at using that scale when you're creating your own maps at home. So these are just a couple of examples in case you want to get started with your own map making at home. We would love to see examples of any of your creations, so please do ask an adult at home to share them on social media. Now then, whilst you're out exploring your local area and creating your maps, you may want to create a memory stick or journey stick of what you see or collect. You can do this with photographs and annotate a map with the photographs, or you might like to get crafty making one of these journey sticks. So for the paper memory stick, which is this blue one in the middle here, just here the girl is holding one that she has created. You need a piece of card. I've got an example of a starting point here, just a piece of card and some double-sided sticky tape to go down the middle, okay? And then you can carefully peel off the sticky tape as you explore your local area and collect items. I suggest that you start at one end of the paper at the beginning of your walk and move all the way down to the bottom. And then that way you're creating a representation of some of the items that you find in your local area. Perhaps you want to collect different leaves to represent the trees in your local area, or different flowers to show which flowers grow in your local area. So for the journey stick, you can see examples of them here and here. You just need to find a stick and wrap some yarn around it before you set off collecting your items. Then when you're collecting your items, try to poke them in between the stick and the yarn so that they stay in position. So have fun making those at home and in your local area this summer. I've got one more idea for you related to maths and maps that you might want to try after this lesson. So many of us are ensuring we continue to exercise every day in the summer holidays. Perhaps you walk, cycle, or run with your family. I like to walk a daily mile to ensure I'm always doing some exercise each day. You could try mapping this in your local area too, focusing on the scale where possible to help you fit everything you want to show in your map on the paper. Let's have a look at this one. So you can see here that I've included an additional feature to my key. I've got a blue line at the bottom of my key there to represent my walking route. Okay, so I've added in that symbol, and you can see that I've now mapped my walking route from the school here, the route that we explored earlier, to my home, the blue house. Okay, and when we used scale to calculate distance earlier on in the lesson, you'll remember that the distance was 130 meters approximately from my home to the school. And you could try adding an exercise route of your own to a map if you want to. So we're just about coming to the end of our lesson on discovering the maths of maps. And today we've looked at different mathematical features of maps, including the grid, coordinates, scale. I wonder if you can now teach someone in your house about the features of a map, or perhaps how to read coordinates of a map. Perhaps you can now help them to calculate distances using the map scale. Maybe you could try some of the suggested activities that you've got up on the screen here, like making your own map, a journey stick, or perhaps recording your daily exercise. I hope you have fun with maths and maps this summer and enjoy exploring your local area, or perhaps even discovering a new place to explore. Thank you very much for joining me today, and I hope you continue to enjoy the other lessons as well as part of the Discover More Festival with Explore Learning. Thank you very much, and goodbye.